In this video, we are going to look at this example. Two particles, A and B, collide with each other as shown in the diagram. Particle B moves with a velocity of 10 meters per second at an angle of 60 degrees with respect to the line ST, and particle A moves with a velocity of v at an angle of theta with respect to the line ST. Find v and theta. The first thing to do here is to place two perpendicular axes, the x-axis and the y-axis, pointed as shown. Then we write the conservation of momentum along the two perpendicular axes. Let's start along the x-axis, and we have PAX plus PBX is equal to QAX plus QBX, where the P's are the initial momenta and the Q's are the final momenta. The subscript X means we are dealing with the components of the momentum along the x-axis. If we write it in terms of the x component of the velocities of the particles, then we have ma uax plus mb ubx is equal to ma vax plus mb vbx, where ma is equal to 5.0 kilograms and mb is equal to 8.0 kilograms. Hence we have 5.0 uax plus 8.0 ubx is equal to 5.0 vax plus 8.0 vbx. Now if we do the same along the y-axis, we have PAY plus PBY is equal to QAY plus QBY, which can be written in terms of the y component of the velocities as MA UAY plus MB UBY is equal to MA VAY plus MB VBY. And if we substitute the values of MA and MB, we have 5.0 UAY plus 8.0 UBY is equal to 5.0 VAY plus 8.0 VBY. Now we need to resolve all velocities, initial and final, along the x-axis and the y-axis. Let us start with the initial velocities. For particle A, we have 20 cos 30 meter per second along the x-axis, and we have 20 sine 30 meter per second along the y-axis. Hence we have uax equals to 20 cos 30 meter per second and uay equals to minus 20 sine 30 meter per second. The negative sign for uay is because the y component of the velocity ua is opposite to the direction of our y-axis. For particle B, we have 15 cos 45 meter per second along the x-axis, and we have 15 sine 45 meter per second along the y-axis. Therefore, we can write ubx equals to 15 cos 45 meter per second and uby equals to 15 sine 45 meter per second. Now let us do the same for the final velocities. For particle A, we have v cos theta along the x-axis, and we have v sine theta along the y-axis. Hence we can write vax equals to v cos theta and vay equals to v sine theta. And for particle B, we have 10 cos 60 meter per second along the x-axis, And we have 10 sine 60 meter per second along the y-axis. Hence we can write VBx equals to 10 cos 60 meter per second and VBy equals to minus 10 sine 60 meter per second. Here again, the minus sign is because the y component of the velocity Vb is opposite to our y-axis. If we substitute all these components of velocities into our equations of conservation of momentum along the x-axis and the y-axis, then we will end up with a pair of simultaneous equations as follows. Along the x-axis, we have 5.0 times 20 cos 30 plus 8.0 times 15 cos 45 equals to 5.0 times v cos theta plus 8.0 times 10 cos 60. Along the y-axis, we have 5.0 times minus 20 sine 30 plus 8.0 times 15 sine 45 equals to 5.0 v sine theta plus 8.0 times minus 10 sine 60. If we rearrange the equation along the x-axis, we have v cos theta equals to 26.29. And if we rearrange the equation along the y-axis, we have v sine theta equals to 20.83. All we need to do now is to solve for v and theta. To obtain v, we square both equations and we add them. So you'll have v square cos square theta plus v square sine square theta equals to 26.29 squared plus 20.83 squared. If you take v square out, you end up with cos square theta plus sine square theta in bracket equals to 1125.1. Cos square theta plus sine square theta is equal to 1. And we have v square equals to 1125.1. And therefore, v equals to 33.5 meter per second after taking square root. To obtain theta, we take the equation along the y-axis and divide it by the equation along the x-axis to obtain v sine theta over v cos theta equals to 20.83 over 26.29. The v will cancel out and we end up with tan theta equals to 20.83 over 26.29. Theta is equal to tan inverse of 20.83 over 26.29, which is equal to 38.4 degrees.